Given the opportunity to talk about digital twins, especially in the confluence between construction and operations, Kaveh and I are going to walk through a few topics we believe are going to be pivotal for the industry. And we're going to try and organize it around three pillars. The first pillar is around strategy and planning, how to optimize a portfolio, how to optimize an asset strategy. And the second focus area is going to be around how construction handover especially has a significant impact on operations, and digital twin enables success in operations. The third piece would be around operations itself. How do digital twins transform operational workflows for different stakeholders and different use cases within the operations? So Kaveh, over to you. Would you, firstly, great, we could share the stage. Would you like to kick it off with your perspectives on the first pillar?
Starting with the sort of commercial side of things, the financial side of things, I think one of the most interesting things going on right now with digital twins is the movement, in addition to the more, let's say, traditional use of the management and simulation of the physical asset, whether it's the energy, the environmental and other sort of physical impacts of the assets, is we're starting to use them for the commercial planning, the portfolio, the asset mix optimization, and starting to be able to look at the financial models and tools with it too. I mean, in the end, the digital twin is a simulation tool, right? It's an advanced analytical tool that can then move into other directions and help you operate, yes, but the sort of initial magic comes with the fact that you are simulating different scenarios, testing things out in a sort of safer environment. And we're starting to do that with the financial modeling. So we can look at some of the, take a larger mixed use asset, hospitality, has some retail, maybe even residential in it. There are a lot of different ways to mix the components of that, and not only being able to plan the construction and then get into the handover and so on, that you described the move to, but being able to now compare cost models across some of these different mixes and designs. So I think that's a very interesting shift that's happening at the building level. It's been happening more at the broader level. It's happening more now to even districts and cities. And so one of the things that's doing is it's raising the question of the value of that digital twin itself as part of the asset. So in addition to your physical asset, you've now got a digital asset that goes along with it. And the digital asset includes the data that you're collecting, the digital twin, and there's a slippery slope then into the actual sort of the metaverse twins too. So I think there's a fantastic opening right now where we're looking at simulating the financial components and then valuating them, and actually being able to look at the digital twin as part of the asset itself, and how much value does that add for an operator, for an asset owner or an operator, or if you're trying to package something up for the investors as an investor.
I mean, that's really great points there. And especially when you consider that there are so many different types of data involved in a digital twin of that nature. Because traditionally, when we talk about digital twins, the first impression people get is, oh, some 3D models and GIS and some of that stuff. But many times it's ignored, or it's not transparent that the digital twin is really about the data model and the different data sources. And the scenarios that you described there, Kaveh, there are so many different data sets, ranging from demographic data, economic data, mobility data, land uses.
100%. And let me actually turn that back to you, if I may, because when you look across all these different data sources, I think one of the traditional issues we have with data in every instance, but certainly in this case, is that they end up being siloed too often, right? They're coming from different places. They're being managed by different teams. The value in data is in its sharing, right? It's in having data that can be accessed, analyzed, combined. So maybe this is an area of expertise for you. Maybe you can tell us a little bit about all the different sources of data and how digital twins, especially in those transition periods, the project handover, for example.
Everybody in this room, whether you're from the construction world or you're in the operations world, are fully cognizant about the fact that information is produced right through the entire life cycle of an asset. It's produced during planning, it's produced during design, it's produced during construction, during commissioning, and in operations. And the operations requires information from pretty much every stage prior to that, right? And traditionally, handovers have been really bad. Whether it's handover from design into construction or construction into operations has always been a challenge for very good reasons, because even the way assets are created, there is the whole process of creating an asset is rather broken. So there are different stakeholders and expertise involved at every stage. And there are different sets of people who come in to deliver their areas of expertise. And there is naturally a problem with using data, making data seamless and flow right through the life cycle across many organizations, across their different ways of producing it, the ways of storing it, and the ways of disseminating it. So this has been a problem. But if we want to focus a little bit more on the handover problem between construction and operations as one topic, I think this is an area where every asset owner, operator needs to and are beginning to focus on quite heavily. Now, how do we make sure that the information that we only target, firstly, the information that we care about? There's so much of information produced during design and construction that may not be material for operations. Trying to chase for everything is going to be a problem, right? But even if we have to know what we need, and once we know what we need, we can then streamline the process of information production. So if there is BIM involved in a project, for example, we need to make sure that the models are properly classified, properly defined in respect to what data do we need about every type of equipment or system or space, how to validate it. Because in the end, a digital twin is a machine readable environment, right? So you have applications interacting with the twin, making use of the data to drive their workflows. So how do machines interpret data? It's only by structuring them properly. A human, obviously interacting with the system, can figure out what things are by looking at it and querying it. But if a machine has to understand, it needs to just simply know. So structuring the information, making sure that everybody in the ecosystem knows what are they responsible to deliver, and they need to be contracted to deliver that as well. And then bringing it together in a platform that should do two things. So firstly, digital twins needs to be thought about as a set of solutions, not as a product, right? So we need to think about twinning as a process. So which means you bring together all the information that we need to create this world model of that asset or a portfolio or a city or whatever it may be. So having that world model in a platform that allows you to leverage it and create multiple solutions targeting specific use cases is really important. And here is where I think the topic of the conversation today also fits in very well, because expertise to drive, whether it's maintenance, whether it is energy management, or whether it is wellness, or whether it is carbon. So each of those workflows, use cases, have different expertise. How does an asset developer create digital twins that address each of these use cases individually without having to twin their world multiple times? That's really a challenge, and it can be solved. So the process of handover, if it can be targeted very, very specifically, and if the asset owners can make sure that constructors who produce the asset, not only they deliver a physical asset, but they also deliver a digital asset that is on a platform that can be then consumed for building out those applications and operations, would be the perfect world. And this would then mean that the contractors would need to be incentivized to produce it, right? It's not going to happen without any deliberate effort to do so. It needs to be scoped, it needs to be defined as a requirement, and then the contractors can find the right solutions to put it together. And once that's done, you have a very good foundation for building up your operation strategy.
A little bit. So, you started talking about the operationalization of the tool. So not just using the tool in operations, but now that you have a tool, how do you make it an integral part of your core business, of the way you actually run your business? And this is a problem with technology time immemorial, right? This isn't just a digital twin issue. We've had exactly the same challenge with all the early data work, just getting a single source of truth for data in data warehouses and then creating reports and dashboards off it is great, but that doesn't mean that it's going to now be properly used in decision making. It doesn't automatically mean that you now have insights you didn't have before. You may have data you didn't have before, but have you put it through the value funnel and turned it into usable insights, delivered it to the right people at the right times in the right places? And this process of setting up what I think of as an insights function, that combination of those experts you described, that the technology is, and in this case, the digital twin is simply allowing us to bring enough high quality trusted data into one place so that we can now figure out how to build it into our work, how to deliver it to the right person at the right place at the right time, right? And to me, that opens up the very, very interesting connection with what you see happening all over the world, certainly at the city and national level with the data sharing and open data initiatives. It's exactly the same thing we're talking about here. By bringing data together and sort of creating this ecosystem of insight generation and data sharing among the experts, we're actually, we're creating an entirely new asset that itself has value and can therefore generate new commercial opportunities, new business models, just based on now you've got these folks together, right? My favorite example is being able to connect the digital twin ecosystem of any building with the smart city data and ecosystem that comes from their smart grid. Whether it's being able to understand your impacts on the energy usage or sell back in those places where your building is generating solar energy and you have the opportunity to sell it back. So there are just a whole universe of new possibilities here. And I'm curious for your take on some of that.
When we start thinking about digital twins as a set of solutions that are created on a world model, and these solutions are created by domain experts who bring the professional services, who have an understanding of the physics behind what is happening and all of the science behind it. So it could be a designer, it could be a mechanical consultant, it could be obviously the contractor is involved in delivering a twin at the end of construction. So there is new services there. But then the engineering firms, for example, who have the expertise in creating or designing those assets, they know the performance expectations. If they could assist asset developers to optimize, to track the performance and optimize the performance of those assets, and even learn from it to see that how can they improve their designs in the future. All of these are completely new opportunities. I mean, whether it is for the designers or the contractors, and even later in operations, whether it could be completely new modes of delivering services to operate assets. I mean, remote monitoring has always been there, but now we are talking about remote monitoring with a level of context and insight, which is like never before. So you can practically diagnose problems. You can not only know that there is an anomaly through algorithms that track how things are, what's happening, but you can then diagnose that problem, go to the root cause, and address the root cause to save energy. And this is a huge issue given the whole focus on ESG for every asset owner, not only commercial properties, but any asset, any owner, any organization that owns assets are extremely concerned about optimizing the carbon footprints of their portfolio, optimizing the wellness of the people working within them. And ESG is going to be as we all know, is going to determine whether an asset is tradable, investable, and so on. With that remaining in focus, using digital twins to be able to understand system and equipment behavior and finding anomalies, making sure those are the root causes are diagnosed, and then seeing the loop closed. Because just because you know there's a problem, you don't solve the problem. You don't save energy. You don't save cost. We need to have mechanisms to act on it. So integrations are going to be key. How do I generate that insight into an action which somebody has to deliver, and then I want to close the loop and see the impact? So the next time I can then decide, do I want to chase that particular tail or not? The opportunity to leverage digital twins by an ecosystem and creating new digital economy contributions is a very real scenario, and we're beginning to see that getting played out as we speak.
You mentioned, some of the automation in the responses that can happen, right? So as we have all this data in one place, and as we have it historically, we can start to apply the machine learning and AI models that can learn from that and do, like you said, predictive maintenance, actually just respond. Some of those things can be more automated. Again, some of the more traditional energy and sort of carbon footprint, environmental management. Some of the stuff which is a little bit more human behavioral and requires that human intervention can also still benefit, though, right? It doesn't have to be fully automated in order to benefit from that degree of AI and machine learning, even if all the system does is narrow your options, is highlight when things are out of the control range, is draw your attention as a human where you now need a human intervention touch. For example, in the financial modeling and in the earlier work that we were talking about, you're not going to just automatically change the asset mix to some machine identified optimum. You're going to look at your strategic mandate and so on, right? But it narrows the options. It helps point to the best possibilities. So for me, these are the sort of intractable problems of managing human behavior in a city, in a campus, in that environment. Right. And even then, what we're finding is that these technologies and having this data in one place is really helpful. So,
absolutely. But I do want to, however, caution a little bit, right, in terms of expectations and aspirations. I think the industry has huge aspirations from machine learning and AI and automation. I hear more people talking about autonomous buildings after autonomous cars. Why not autonomous buildings? These conversations are happening. Now, I do think it's important for every one of us to recognize that these things do not happen automatically. We need to be very, very deliberate about how we shape our data, going back to the earlier point. So if you're an owner of a portfolio, you probably have many different asset classes in your portfolio or types of buildings in your portfolio. You mentioned commercial and residential and maybe infrastructure assets even, right? So each of them and every instance of them. So you have a certain type of commercial, let's say a commercial building is a type of asset, but every individual commercial building is going to be unique. It has a different number of floors, it has different types of systems, it has so many different variations. Now, if you have to apply our technology, and whether it's AI or whether it is just even plain enterprise applications interacting with these buildings in a consistent way, every building needs to talk the same language, right? So the notion of implementing an ontology to describe your asset portfolio, the notion of making sure that we know what entities within that building do we care about, what are the relationships between those entities. So for example, how many floors does the building have? What are the spaces within them, the mechanical spaces, the rooms and the apartments or the offices? How are they composed into zones for different services, for HVAC, for heating, for energy or for lighting? And how are those zones serviced? What are the systems? What are the equipment that make up those systems? So there's a lot of different, if you think about it just from data science point of view, ignore the physicality of a building. You can express every asset in a data-centric way, and that's really the digital twin. And once we are able to do that, There can be visualizations to it, of course, either at a building level or a GIS level for large geographically distributed assets.